All right, so the one I want to do is number 33, cheddar cheese consumption. Okay, so let's go ahead and read the problem and first write the claim as a mathematical statement. So it says a consumer group claims that the mean annual consumption of cheddar cheese by a person in the United States is at most 10.3 pounds. A random sample of 100 people in the United States has a mean annual cheddar cheese consumption of 9.9 pounds. Assume the population standard deviation is 2.1. So at alpha equal 0.05, can you reject the claim? So let's first identify the claim. Okay, so I know I'm talking about mu because the claim is about a mean. Okay, so I'm going to write, is that working? Okay, so I'm going to write mu, what am I going to put here? At most. Okay, so that's going to be less than or equal to 10.3. Okay, so that's the claim. Do you guys see that it's going to be less than or equal to in this case? Is it down? Oh, I need to move down. Ah, sorry. Didn't say these had to be good. Okay. Okay, is at most 10.3 pounds. So that's the claim. Does this contain the case of equality? Yes, so this is going to make this the null. So by default, the alternative is going to be greater than 10.3. Okay? So this is going to be an upper tail test. Oops, I better move it over. Okay, so let's go ahead and find the standardized test statistic. Okay, so the formula is x bar minus mu over sigma over the square root of n. So in the problem, we're given that x bar is equal to 9.9. Our sample size was 100, and the standard deviation is assumed to be 2.1. Okay, so just plugging into this formula, I think I know what the problem is. I need to zoom out a little bit. No, it's not letting me. Oh well. Okay, so plugging into this formula, I get 9.9 minus 10.3 over 2.1 over the square root of 100. Okay, so plugging that into the calculator, okay, looking at this numerator, I expect my test statistic to be negative because that sample mean is below the hypothesized mean. Okay, so did you guys get negative 1.905 approximately? Okay. All right, so I want to find my critical value. Okay, so since this is an upper tail test, I'm going to shade a region of 0.05 in the upper tail. Okay, so I need to draw my bell curve. Okay, so I'm given a level of significance of 0.05, so I want 0.05 area in this upper tail. So I need to find this corresponding critical value. Okay. Wait, what's going on here? Oh, okay, sorry. I'm like, wait a minute, this is a lower tail test, but it's not, it's an upper tail test. Okay. Already looking at this, I know what I'm going to do. Look at this test statistic. It's negative, right? And my critical value is going to be positive. Okay? So I'm thinking we're going to fail to reject the null. Okay, in this case, but let's go ahead and work through it. Okay, so in this case, you could go ahead and use inverse norm and a cumulative area of 0.95. Okay, so what do you get for that critical value? I should have these memorized. 1.645? Okay. Okay, so looking at where the test statistic lies with respect to the critical value, we're way over in the fail to reject region. In fact, we're almost 2 standard deviations below the mean. Okay? So we're down here. Okay, so Z star is down here. So in terms of extremity, because this is an upper-tailed test, my p-value is going to be going this direction. Okay, and because it's a single-tailed test, I don't have to double that p-value. So to find the p-value, I'm going to find the probability I get a test statistic greater than negative 1.905. Okay. Okay, so again, this goes back to chapter 5. Okay, so this would be section 5.1. Okay, so I'm going to go ahead and use my normal CDF here. Okay, my lower bound is negative 1.905. My upper bound is a super large number. And then I can close parentheses. Okay, so doing that, I get a p-value of 0.9716, okay, approximately. Okay, so now let's go ahead and compare the p-value to our level of significance. Okay, so the p-value is 0.9716. Our level of significance is 0.05. Okay, so is my p-value greater than alpha, or is it less than or equal to alpha? It's a lot greater than. Okay, so I'm going to put greater than. So when your p-value is greater than your level of significance, we're going to fail to reject the null. Okay. So looking back at our null and our alternative, if we're failing to reject the null, it means we're in favor of the null. We're going to keep the null. Is our claim supported? Yes. Okay, our sample statistic of 9.9 does support the claim that mu is less than or equal to 10.3. Okay, so let's go ahead and get a confidence interval. Okay, we're failing to reject strongly here. Okay, that's why I had to stop and look at it, because this is an upper tail test. So my critical value is going to be positive, but when we calculated the test statistic, it was negative. Okay, so that gave me a little bit of a warning. I'm like, whoops, did I set my null and my alternative up correctly? Okay, but rereading the problem, at most, is less than or equal to, so we're good. Okay. All right, so going down to the confidence interval, if alpha is 0.05, then I want a 95% level of confidence. Okay, so I'm going to go back to the calculator. Okay, just to refresh your memory here. Okay, I'm going to go to stat, then tests, then scroll down to Z interval. And I have the summary statistics, so I'm going to go ahead and put in the information. Okay, and the confidence interval looks good. Okay, so our confidence interval goes from about 9.49 up to 10.31. Okay, so looking at this confidence interval, This is a range of values likely to contain mu. Does this confidence interval support failing to reject the null? The confidence interval limits go from 9.49 up to 10.31. Is most of this confidence interval below 10.3? Yes. Okay, this confidence interval is not above 10.3. Okay, so the confidence interval is supporting failing to reject the null in this problem. Okay, did you guys all get that confidence interval? 9.49 up to 10.3? Okay. So after this, I would have to write my conclusion. Okay, since I'm failing to reject the null, okay, I'm going to say there is sufficient evidence to support the claim that, okay, so what's the claim again? You go through this problem, it's been so long you forgot what it is. That the mean annual consumption, sorry, trying to find room here, of cheese is at most 10.3 pounds. That seems like a lot. Okay, so just real quick, to get this on your calculator, okay, remember the calculator won't make the decision, but it will give you the test statistic and the p-value. Okay, I'm going to go to stat, right arrow over to test, and my first option is the z-test. Okay, again, I'll either have the raw data in a list or I'll have the summary statistics. Okay, so I'm going to put in the parameter from the null, okay, and that was what, 10.3? My standard deviation was 2.1. It carried it over from the confidence interval screen, and it kept the sample mean and sample size. Okay, so I have to change my alternative. Okay, so I'm going to change that to greater than, and then press calculate. Okay, so is that the same information that we got when we did this quote-unquote by hand? Yeah. Okay, so we're definitely in favor of the null in this case, and we are supporting the claim.